So it's a good idea that if I'm looking at a graph and going to interpret the graph, I better be looking at an entire graph of the polynomial function. And that's another thing we have to keep in mind if we're going to use the graphing calculator, because sometimes you might only be looking at a portion of the picture and be making all your conclusions based off of that. Meanwhile, it may in fact have some rational zeros or roots. You're just not looking at a part of it where that would actually happen. So knowing some things about how these graphs should look would also indicate to you whether or not you're looking at enough of the graph before you start trying to figure out where all your possible zeros are. So, number one, it says polynomial function graphs are smooth curves. They have no asymptotes, breaks, or corners. Some general guidelines. If I have, this is the way I state them, okay? If I have an odd degree polynomial, which means that the highest power of x I have in that polynomial is odd, then I'm going to expect that the two ends of the graph are going to point in opposite directions. Either one's going to point down and one's going to point up, or one's going to point, or the left's going to point up and the other one's going to point down. So, for this one here, it really depends. I mean, if A is positive, I'm going to have the left-hand side being in the negative area or pointing down. The right-hand side is going to be pointing up, and vice versa if A is negative. That's somewhat important, but again, if I'm only seeing part of the graph, and I know and this could be different in different ways, but if I know it's an odd function or an odd degreed function, here's my coordinate system that I have, and I see the graph doing this. The question becomes, am I looking at enough of the graph? Well, this would indicate if I was looking at that and that's all I have, that seems to be behaving more like an even function or an even powered function because, an even powered function or an even degreed function, I should say, the two ends are going to point in the same direction. And here it looks like the two ends are pointing in the same direction, but I'm saying, hey, this is a cubic. Well, that means that more than likely, I'm either missing where it's coming back around up here to have them point in different directions, or I'm doing it on the other side that's doing the same thing. So, that lets me that this rule kind of gives these two rules together kind of giving an indication whether or not I'm looking at enough of the graph. And therefore, if I'm not looking at enough of the graph, I might be missing additional zeros that I need to test out to see if they're rational or not. So, given some explanations and some descriptions of what a polynomial graph looks like, let's see how many of these are polynomials graphs. A, well, I see it's a smooth curve. It's continuous, no corners, no breaks, no asymptotes of any kind that I can see. Therefore, just by looking at what I have here and only based on that, I would say that more than likely that's going to be that is going to be a polynomial function. It's going to be an odd degreed one because I'm looking at the entire graph, and I'm going to probably guess that's probably right because I have as her going to like 4 or 5, but you're already past 4,000. So it's going to probably keep going up and up like that forever and ever. So it's an odd degree polynomial. There you go. For B, I see breaks throughout this graph. I mean, I do see a break in the middle, where that one piece looks like it's a little bit, this middle hump here got broken off and moved down a bit. So this is not continuous. And if it's not continuous, it is not going to be a polynomial function. C, again, smooth curve. It's an even degree polynomial. So I see it, smooth curve, two ends pointing in the same direction. D, smooth curve again, indicates it is a polynomial function. The two ends are pointing in opposite directions. It's going to be an odd degree polynomial function, and it's probably going to be an odd degree polynomial function where your leading coefficient is negative. And for E, we have this function here. Another type of function you tend to get when you deal with rational functions, have like asymptotes and things in them. We're going to look more into that momentarily. But this thing obviously has a few breaks in it. And if it has a few breaks in it, and there's a few areas where, like what's happening at x equals -3, what's happening at x equals 8? Because the graphs seem to be avoiding those areas and getting really close to them and saying, still not going to come near you. So, This one here, the the break is these two breaks are showing me that it is not a polynomial function.